morning students, myself Badi Alekhya, Assistant Professor, Department of Artificial Intelligence and Machine Learning, Rmdec Engineering College. Today we are going to discuss about one of the most important concepts under first order logic, quantifiers. So to solve any types of knowledge representation sentences in AI, so quantifiers plays a very important role. Let us start with the topic quantifiers. So quantifiers, it is one of the basic elements of first order logic. When we are representing any language elements, quantification will represent that how much of discourse we are going to giving to the information. So to represent that range and scope of the variable in a logical way, we have two types of quantifiers. We are, in simple words, we are using two symbols to representing the quantifiers to determine the scope of the variable in a logical expression. So what are those two types means? One is universal quantifiers and second one is existential quantifiers. Here universal quantifier will representing in your given statements or sentence, it is representing everything, everyone, for all, means we are going to prefer which type of quantifier mean universal quantifiers. So in your given statement or sentence, if you are going to represent some part or something, or if you are going to represent at least one, for that type of representation we are using existential quantifiers. Let us clearly understand in which way we are going to represent these quantifiers and also discuss some of the examples how to represent that sentences into first order logic by using quantifiers. So first we will start with universal quantifier. Universal quantifier is a symbol of logical representation, so that already we know. When we are specifying some particular statement, it is representing the statement range is true for everything, and whatever the things presented in that particular thing, that every instance will covering true value only. So how we are going to represent, how we are representing this universal quantifier by symbol means it's a inverted A. If you observed here, the universal quantifier is represented by a symbol inverted A. And also remember one noted statement here, this universal, when you are going to implement any universal quantifier statement, we have to use implication. And let us move to the representation of universal quantifier. For example, if x is a variable, then for all x is read as, this is inverted A is representing universal quantifier. This we can also read it as for all x, for each x, for every x. That means it's representing the entire everything, every instance presented under the variable x. Example, clearly how we are going to convert a normal sentence or statement into predicate logic by applying universal quantifier. Here example, all men drink coffee. What is the meaning of that thing? Mans who are all belongs to the category man will surely drink coffee. So if you see, observe the keyword all here. Which type of quantifiers we have to use? Universal quantifiers. So if you are observing here, I am going to take one variable. Put it in your mind, when you are representing any universal quantifier, you have to represent that symbol with a variable. So here for representing all, I am using the inverted A symbol followed by the variable x, man of x. What is the meaning of that man of x means? We don't know the name of the man, that is represented by x. All mans, that man of x will represent before the inverted a symbol. If you are carrying the x variable with inverted a symbol, it's representing all man. Here man of x before that symbol inverted a, if you are carrying, that is representing all man. That all man is, here man is represented by the variable x. So in before slide I explained that you have to remember, whenever you are implementing universal quantifiers, you are going to use represent a implication statement. Implication means arrow mark, and it's followed by drink coffee. Who will drink coffee? All man drink coffee. That man is represented by the variable x here. What's the thing it's going, that man drink coffee. So here it will be read as there are all x, where x is a man who drink coffee. So in this way we are going to applying the universal quantifier and convert the given statement into first order logic. By applying the universal quantifier, how we are going to convert the given statement into first order logic means by using the inverted a symbol. Two things we have to put it in your mind. One is a symbol, inverted a symbol for representing universal quantifier, and the implication symbols to represent the relationship between the objects. Now the second type of quantifier is existential quantifier. Existential quantifier are the top type of quantifiers which represents the statement. So there for everything the scope is true. Here for at least one instance the scope is true means that is represented by which type of quantifier? Existential quantifier. There universal quantifier is represented by inverted a. Here existential quantifier is represented by inverted e. It's one of the predicated variable, that's why we call it as existential quantifier. Note there in universal quantifier we are always using implication. Here in existential quantifier we always use and, or otherwise we call it as conjunction. In symbol it represented by inverted e, v, inverted v. So let us discuss with one example what is existential quantifier. If x is a variable, then existential quantifier represented by inverted e of x, and it will be read it as there exist of x for some x for at least one x. So existential already we discussed, for something we have to use this symbol. Let us take one example, sentence, some boys are intelligent. Here they are not representing all boys are intelligent. If they are giving all boys are intelligent means you have to consider universal quantifiers, but here they are giving some boys are intelligent. If they are giving some, only some, at least, exist, there exist, like that keywords if you are seeing in your sentence, which type of representation or which type of quantifiers you have to follow? Existential quantifiers. So there exist of x or some boys is represented by this symbol inverted u of x. Here x is representing boys. So among that boys some are intelligent, that's why intelligent of x. Instead of implication why I am using and, here we have a rule, when you are using existential quantifier you have to use the symbol conjunction. So that's why we are between the boys of x and intelligent of x we are using the symbol conjunction. So when you are going to read, there are some x, here x is representing boy, that boy is intelligent. I think so it's clear for you guys what is the representation of universal quantifiers and existential quantifiers, in which way we are going to variate the representation of universal quantifiers and existential quantifiers. Let us see some of the properties of quantifiers. In universal quantifiers, for all of x, for all of y is similar to for all of y and for all of x. It's symbols both are same. If two sentences is there and two are representing only one type of quantifiers, now there is no issues. Like in existential quantifiers also, if you having xy, xy is representing same type of quantifiers, means if the order or interchange mean also there is no problem. But if a statement consisting of one existential quantifiers and another universal quantifiers, it's not similar to the another thing. If you are exchanging or swapping that things, it's not similar. That things you put it in your mind, uh, in which way we are going to consider it as same or different. So the combinations is not similar. If both are representing the same type of quantifiers, means there is no issues, both are similar only. Let us see some example to understand the properties of quantifiers. All birds fly. In this question, the predicate is fly of bird. Predicate is fly and bird is the term. So all, if you represent all and you are going to apply, all is represented by which quantifier? Universal quantifier. For all of x, so here the bird are represented by x. When you are using universal quantifier, which symbol you have to use? Implication, this arrow mark, and fly of x. Who will fly? Birds will fly. That birds will be represented by which variable under universal quantifier? X. I think it's clearly understand to you guys. Here predicate followed by terms. All birds fly means all is represented by inverted A and birds is represented by the variable x. It's called under the parentheses. When you are using universal quantifier, is represented by implication symbol and fly of x. Every man respect his parent. In this question, every man also represented by which type of quantifier? Universal quantifier. Every man respect his parent. Here two subjects we have, that is two terms. Here respect is the predicate. Predicate is respect of x comma y. Here x represent man and y represent parent. Since there is every man, so we have used inverted A. This inverted A represent universal quantifiers. So for all of x, man of x representing, x is representing the man, implies respect x comma parent. If you consider y also, there is no issue. If you for every man only they mention, every parent they didn't mention. That's why I am considering the x for universal quantifier, not for y. So here man is represented by which variable? X. Respect is the predicate. The first predicate man will be represented by the variable of universal quantifier is x comma parent. They didn't mention that every man respects his every parent, not like that they mention. So in that way, when you are going to represent this statement, for man only you have to apply universal quantifiers. Some boys plays cricket. Let us see some other example. In this question, again some boys are represented by x, boys are represented by x and cricket is represented by y. Here play is representing as a predicate. So x boys, y game, but some boys they will mention, for that's why we are applying some will be represented by existential quantifiers. For boys only we are going to apply the existential quantifiers. If you observe that there exist of x, boys of x, here boys is represented by x. After, sorry, some mistake is there, I am extremely sorry for that. If you are going, don't give implication here, you have to use and symbol here, and play of x comma cricket. When you are using existential quantifier, you have to mention and symbol. By mistakenly I type it here. So there exists of boys of x and play of x comma cricket, because some boys represented, that's why the some boys are represented by x and the second term is cricket. Let us see some other example. Not all students like both mathematics and science. In this question, the predicate like x comma y, everybody know this predicate is like, x is representing student and y is representing subject. Subject is consisting of mathematics and science. Since there are not all students, so we will use universal quantifiers with negation. All students means universal quantifiers. Not all students means you have to use negation. So the following representation will be negation of universal quantifiers. The students is represented by x, student of x. So if you are using universal quantifier, you are using implication symbol like x comma mathematics. What is the meaning of x comma mathematics? We have two subjects under y, x comma mathematics. Here x is representing the students, and like x comma science. Why? It's a and is a conjunction symbol. So under the predicate like, one subject is mathematics and another subject is science. So it's very easy to write the predicate logic by using universal quantifiers and existential quantifier for the given statement. Let us discuss with some other example. Only one student failed in mathematics. Only one student. That means here in this question, what is the predicate? Failed is the predicate. Under that predicate, what are the two terms? One is student term, another one is subject term. Student term is represented by x and subject term is represented by y. So when you are going to look at this example, only one student means which type of quantifiers we have to use? Existential quantifiers. If you observe here existential quantifier, there exist of x, student of x. Again I did a mistake. Instead of implication I have to use and. If you are observing that failed in mathematics, so you can write it in another way. There exist of x, student of x failed in x comma mathematics. In this way you can write. And for all, this is some complication. If you are going to represent only one student if failed in mathematics means, first we consider one student. There is only one student. There is only one student means student of x failed in x comma mathematics. And for all of y means subject. Here it is representing subject. Negation of x equal to y means, what is the meaning of not equal to y? And that at that time you are going to use the implementing the condition and student of y, that students implies not failed in mathematics. That means only one student failed in mathematics, not that remaining students all will pass the mathematics. We are going to combine those two conditions, means we are going to get exact how which student is failed in who we are going to write the exact frame sentence how one student is failed in mathematics. It's somewhat typical. If you practice again and again, you can come to conclusion how to write the statement. If you are in the fifth statement, you have some confusion how to write. If you frame the sentences, first we are going to considering there exists one student. Some student is there among all student. One student who remaining, we are going to combine with the students those who are not failed in mathematics, not failed in mathematics. And if you are going to consider which one is add man out from that student means, then we can find out that one student failed in mathematics. This is the inverted mechanism. You don't think that this is the exact way you have to write the predicate logic in your own thing without disturbing the syntax and semantic of the particular sentence. We can write the universal quantifiers and applying the predicate logics for the given sentences. I think so you understand what are universal quantifiers, in which what are the symbols we are using for universal quantifiers, at which scenarios we have to use universal quantifiers, and what is the symbol we have to use for universal quantifier. At the same time, existential quantifiers, in which way we are going to represent existential quantifier, in which scenarios we have to implement existential quantifier, and what is the symbol we have to use between the statements of existential quantifiers. That's all students for the today's sessions. I will meet with some other new concept in the next sessions. Thank you very much.